Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm answering a question here from my end of topic worksheet on differentiation from P1, and it's a question taken from the June 2018 Pure Mathematics Paper 1 from the UK GCE AS, not the International A Level AS P1. This is a Paper 1 from Pure Mathematics GCE from the UK. Now this is actually something which is mentioned, it's in the P1 book, the International A-Level P1 book, but it's mentioned that this will not be examined. And you won't find a question directly like this saying prove from first principles the derivative of x cubed is 3x, something like this. You won't be asked to prove from first principles. However, it's something which, one, it's useful for us to understand. Two, there are some questions like question number 12 from the end of topic worksheet, which is from the International A-Level paper, which kind of like, if you understand what to do here, you'll understand how to do those type of questions a lot better. So it's based upon that question. So really, to understand how to do this is kind of like important for us even in the International A-Level syllabus. So that's why I've put this in my end of topic worksheet. And that's why I go through the exercises in the book on this topic. So I'm going to explain this for one of the students who has asked me to go through this question. And so that's what we're going to do. So I'm going to prove from first principles that the derivative of x cubed is 3x squared. I mean, what we know is we multiply by the power and take one from the power. So you get 3x squared straight away. But we're going to prove it from what's called first principles. Okay, so what I'm going to do to make it more understandable, I'm going to make first a little sketch of a part of the curve y equals x cubed. So we know that y equals x cubed looks something like this. It comes from this side underneath, and there's a point of inflection at the origin, has a zero gradient, but then it goes up like this and it starts to rise quickly. That's basic sketch of part of y equals x cubed. So when we are finding the derivative of a function, we are finding the gradient of the function, the gradient function for this. Okay, so I'm going to take a point, a random point, I'm going to call it P. Okay, this point P has an x coordinate over here, that's the x coordinate, and that's the y ordinate. That's the x ordinate, that's the y ordinate. So together they give you the coordinates of this point P. Okay, so this point P, let's say its x coordinate, let's call it x, and the y coordinate, let's call it yp, right? So this is x. Now, the y coordinate of P, okay, is in terms of x, will be what happens when you replace the x, okay, with the coordinate. Like if x was 2, this would be 8. If x was 4, this would be 64, 4 cubed. So if I call the x coordinate x, the y coordinate in terms of x will be x cubed. Okay, so that's x, and that's what comes out of the function when you put x into the function. Then I'm going to choose another point, and I'm going to call that point Q. Okay, this point Q. And I'm going to do this so that the point Q, the point Q has an x coordinate such that the distance between it and the other point x, the other point, the coordinates of Q, let me just get this line sorted out. The distance between the x coordinate of P and the x coordinate of Q, okay, that there's a little distance between them of h. So the x coordinate of this point Q would be x plus h. So the point Q has an x coordinate, x plus h, okay, and this would be the y coordinate of Q. Okay, this would be the y coordinate of Q over here. I'll call it yq on this part here. And it's the y coordinate in terms of x would be the x coordinate of Q cubed. So x plus h cubed, because the function is y equals x cubed. Whatever x is, you cube it to find what y is. So those are the coordinates of p and q, all of in terms of x, in terms of the variable x. Okay, now what we're going to do here is we're going to find the gradient of this chord PQ. We're going to find the gradient of the line between P and Q. Okay, that's what we're going to do first. So we're going to find the gradient of PQ, okay, as if it's a straight line. Well, it is a straight line between P and Q. All right, now we know that the gradient of a straight line is the change in y, y2 minus y1 over x2 minus x1. So we have, these are our 2 points. So we can say that the gradient of PQ, okay, is equal to, we have y2 minus y1, so you have x plus h cubed minus x cubed, that's the change in the y coordinates, over the change in the x coordinates, which is x plus h minus x. Okay, so that would be the gradient. I'll write here the gradient of PQ. So the gradient of PQ is equal to this. So what I'm going to do now is I'm going to expand this bracket. As this is P1 work, I'll just expand it in the original way, which is x plus h times x plus h squared. Now we know x plus h squared is x squared plus 2xh plus h squared. It's just x plus h times x plus h squared, which gives us this. You got your minus x cubed all over x plus h minus x. Well, the x's cancel. You're left with just h now underneath. Now I'm going to expand this bracket. So I have x cubed plus 2x squared h plus xh squared. So I multiplied x with these 3, now h with these 3, plus x squared h plus 2xh squared plus h cubed. Then I've got minus x cubed from there, and all of that is over h. So that's going to give us x cubed and x cubed cancel out. 2x squared h plus x squared h is 3x squared h. xh squared plus 2xh squared is again this time 3. This is xh squared this time. And finally we've got this h cubed at the end. And all of this is over h. Now, what I can do here, I see there's a common factor of h in the numerator, which I'm going to take out. Then I've got 3x squared plus 3xh plus h squared over h. And what happens now is the h's cancel out. So I can say that the gradient of the line PQ, the gradient of PQ is given by this expression 3x squared plus 3xh plus h squared. So that's the gradient of this line PQ. Now, if I make this line PQ get smaller and smaller and smaller, okay, so the distance h gets smaller and smaller from x until it approaches 0, eventually I'll get the gradient at P. Okay, so the gradient at P, okay, would be found by making h approach 0. As h, which is this distance here, gets less and less, the point Q gets closer and closer to P, and the gradient of this chord here becomes the same as the gradient at P. So we can say that the gradient at P, okay, so we can say the gradient at P, which I'm going to call dy dx, is equal to the limit, okay, as h becomes close to 0 of this expression 3x squared plus 3xh plus h squared. Okay, so as h becomes 0, this becomes 3x times 0 plus 0 squared. Okay, you're left with, you basically got 3x squared plus 3x times 0 plus 0 squared. What does that leave us? It leaves us with 3x squared. So therefore we can say that dy dx is equal to 3x squared, which is what we had to prove. Okay, so that's how we can understand how to derive from first principles. Okay, so you basically choose a point, call it x, and then the y coordinate will be whatever the function is in terms of x, right? So y equals x cubed, you write x cubed here, x and x cubed. Then you choose a point that's a little bit away from the point that you chose, and you call the x coordinate of that point always x plus h. So that will always be x plus h. And the y coordinate of that point will always be what happens when you substitute that value of x into the equation for the graph, which is x plus h cubed. Okay. And then you find the gradient. So you do x plus h cubed minus x cubed over x plus h minus x. And then you manipulate that algebraically, and you take out the common factor of h from the numerator, cancel it with the h underneath. Now you've got an expression where you can make h become 0, okay, and what you're left with when h becomes 0 is the gradient function. Okay, so that's how you derive from first principles, and this is basically something that is useful for us to understand in the international A-level syllabus, and it will help us with certain questions like the question before this in my end of topic worksheet, which is question number 12. Okay, so I hope that was clear. Now, other questions. I guess from this paper, if I ever get to answer some more questions from here, I will put them in the playlist for this paper, which will be in the area over here. Other questions from this end of topic worksheet that I have been asked to answer, I will put them in the playlist over here. Other questions from differentiation in general, from P1 in this playlist. And you can subscribe to my channel by clicking on the link here. Thank you for watching. I hope that was useful, and see you soon.